Well, I also,
All right, I'm going to get the screen on.
You also have park vectors.
No, my brain.
I don't think it was. And even though this is a course in civil engineering materials, I assume I'll have like a brief side discussion about your analysis project, because it seems to be a topic of discussion. So once the screen decides to turn on. Is it going to turn on? Going to behave? Come on.
I don't think it's been great.
There we go.
Oh.
The screen is alive.
Oh.
I will, I will sort of dim the lights so everybody can get the QR code. I put forward a couple of housekeeping items, and I figure what we'll do today is we'll sort of structure our discussion around like what's going to go into your lab report, because we can just sort of use this as a brainstorming session regarding some of the various sections of your report. Because I do want it to be a high quality submission, but I also want to help out by facilitating some class discussion if we can. But I also know your structural analysis professor somewhat well, and I know you have a project in there, so we can talk about that as well. Okay, so for homework number 6, it's still being graded. What I did is I posted a solution to problem 1, but then a grading rubric for problem 2, because problem 2, like, there's not really a right answer, but I thought you should have some guidance as to how it's going to be graded. But I posted that. Your lab report in here is due Friday at 5 p.m., and then your final homework is due Thursday at 12:30. And I thought what would be good is to just sort of show you this again. If you remember, a few weeks ago, I showed you a sort of a, hey, here it is for the rest of the semester. And what I've done is I've crossed out everything that we've already done. So the only thing we have left is today's lecture, which we're going to talk about the lab report. And I'm going to make some notes here on the board today for some things to discuss about all the various tests that we've done, some observations everybody's made. Because keep in mind, you have to assess not just your data, but everybody else's data. And so since I've got a bunch of folks in the room, we can sort of look at each experiment, look at each group's findings, and see what happened and all that. When we come back from Thanksgiving break, I'm going to have a brief lecture on composites, but I'm also going to talk about just some other things that shows up in the civil engineering landscape, like geosynthetics, just stuff that you're going to see as engineers, and then we'll talk about our Exam 3 review on Thursday. Exam 3 is going to be on basically tensile testing, steel, alloys, etc. It's going to be on timber. It's going to be on asphalt. I may ask you some conceptual questions about composites, but we're not going to really do much math as it relates to composites. The final exam is on Tuesday, December 9th. It's right after the analysis final, so we're going to have the analysis final, have a break, and then have the materials final. So, all at the same time. Remaining submissions. You've got your final lab due this week. You've got your final homework assignment due on December 9th. I am going to do a quick bonus homework where you just upload proof that you've done your course eval. Here's what I'll say about this. I always, every time, I do this in every one of my classes, and what I tell students is that I really am interested in your feedback, good or bad, because I want to be an efficient instructor. And I'll say that this class is definitely not one I normally teach. A lot of what I normally teach is very, applied physics based. It's all numbers on the blackboard. I'm very rarely, doing stuff in the lab. So any feedback that you have for me in terms of like organizing classes, if there's things that you thought could be, organized better, let me know, because if there's anything that I can translate into later courses and whatnot, I want to know. I don't know when that homework's going to open, because I don't know when the course eval survey at the university level will open, but I'll try and open this up right around the same time that the university survey opens. And I'm going to collect those through the final day at 5 p.m., even though I believe that the actual survey closes on December 5th at midnight. In case you forget to upload your screenshot, I'll give you till the day of the final to do that. So I'll give you a couple more days to do that. Sound good? Okay. All right. So did everybody get the QR code? All right. So since I imagine some of you have some questions on it, and I'm here, does anybody have any questions about the bridge project? We've got a couple. Yes.
Theoretically, if your bridge seems to be impossible, if all of your beams are the maximum size, but your deflection is still bigger than the allowed, what's the solution?
Let's have a discussion about that. What's your maximum allowable deflection?
4.266 inches.
Okay, so let's make sure we're all clear on that. The maximum deflection is L over 360, which is 128 feet over 360. But make sure to convert that. Good. Okay, so there's that. May I see your, I'm going to deviate a bit. Can I see your truss? Okay. Let's do a geometry node. Okay, so the nodal coordinates look correct. Okay. So one thing I'll mention is, like, I'm just going to draw a random truss here on the board. Okay. So let's just do that, okay? And let's say that this is 128 feet, and let's just assume for the sake of discussion that you made this 15 feet, like you made it as tall as it possibly could be, okay? And let's say the truss does that and that. Somebody tell me, what are the X and Y coordinates in MassCan of that point right there?
0, 15 times 1.
Say it again.
0, 15 times 12.
So it's not 0, 15, it's 0, 15 times 12, okay? So if you model things in MassCan and you didn't change your nodal coordinates to feet and inches, or from feet to inches, something's wrong, okay? So if you modeled it and, like, the height of your truss, if that Y value is 15 and it's not 180, you did not have consistent units. So that's another reason. Your real loads, how much are the real loads?
196 kips.
Okay. So your real loads sound right, your dimensions sound right, this sounds right. We're going to have to look at your truss later because I don't know why, because it should, let me just say this, you shouldn't have ridiculously high values. You really shouldn't be.
I had that same problem, and it was like what you fixed yesterday about the planar truss.
Did you run planar truss?
I think so.
Like the analysis was wrong.
I'm also having the same issue.
Are you running planar truss instead of planar frame?
I'm running planar truss.
Yeah.
Okay. Anybody? Let's line up. Like, you shouldn't be having these issues. So
some of the forces on, like, my bottom two chords in the center were like 3,000. That felt really high.
that doesn't sound right.
Yeah, I was thinking that some of the forces per element seemed extremely high.
We'll look at it a little bit later. Like, let's do this. Okay. So the other thing I want to mention is make sure that you're running a planar truss analysis and not a planar frame analysis. So if you're running a planar frame analysis, that's in, so you know how you do your geometry, your materials and sections, you do your conditions, then you run the analysis and you get the results. When you run the analysis, make sure and change the option from planar frame to planar truss. If you're doing that, this should work. I mean, so if anybody's still having an issue, let's look at it in more detail. So any other, like, issues with the project other than just, like, having really big answers or big sections? Anything else that's worth mentioning? All right, if you're still having an issue, we'll save some time after class and we'll look at them one by one. Okay, let's talk about the project or the lab report in here, just to sort of make sure we are at least devoting a little bit of time in CE 321 to stuff that's in CE 321. Okay, so here's the assignment, and I thought we would dedicate some time together for this, but I'd also like to discuss the activities in the lab. And I'd like to make some notes here on the board, and I kind of want to be chronological and methodical as much as we can be, okay? So, everybody get those? Okay. All right. So, your lab report will probably be pretty long when it's all said and done with all the figures, the text, description, and whatnot. But I kind of think that the hardest part of the report, so let's sort of categorize what about this lab report is going to be easy and what's going to be hard. Okay, so let's talk about what's going to be easy. First off, organizing the report is pretty easy. It's organized for you. You pretty much know how you need to organize it. You've already got all the data. It might take a little while, but just like transposing that data to Excel, computing some plots, computing some graphs, it's not hard. I mean, it just takes a little while to do it, but I mean, you can do it. Maybe the most difficult thing is knowing what to say. What observations can you make about what you did in the lab? So let's see if we can take our time today. I'm going to bring the lights up so we can see what's going on the board. Let's see if we can guide some of that discussion. Okay? So let's start off with test procedures. Okay, so the first thing that I want to discuss about test procedures is, and I want to be clear, last thing I want anybody to do is hold back. I mean, if there's something that like Patrick and I should have done that maybe wasn't clear, or maybe we did a demo for you and then you've got the handout, maybe there's something we forgot, maybe there's something that was a mistake. Don't hesitate. But let's talk about this test procedure section. So what if, let's go through this. I'm skipping the cover page and the table of contents because I think that's pretty easy. The introduction, I'm skipping that because I think the introduction should be the very last thing that you write, and it should summarize everything that you've done in the body of the report. I don't need to say anything about generative AI, so let's get into the test procedures. So what are you doing in the test procedure section? You're basically saying, in your own words, what you did. Okay? So let's think about what we did. Let's see if we can break that down. So first thing that we did is a calculation for water correction. Okay, calculation for water correction. Next, we mixed the concrete. Right? And by the way, like when I say mix the concrete, that took a while, right? There was a lot to that, right? Because it was, okay, we put the gravel in, we put the water in, and then we turn it for a little bit, then we go up, stop, then we put this in, then we had to, mark time of wetting. So even just like this step right here, there was a lot there. Like that was not just, we just mixed the concrete. So this is a perfect example of what I'm talking about in your lab report where you said, we mixed the concrete. No, there was a lot more to that. There's a B.1, a B.2, B.3. There's a B.3.1. I mean, there's a lot to that. So this is pretty high level. Okay, we mixed the concrete, all right, but ultimately we put that in our plastic tray. What was the first experiment that we did? What's that?
Temperature?
The temperature. Okay, so the temperature. What's the next one? The slump. Okay, next we did air content. And then finally, sample prep. And that's basically what we did for the test procedures. But keep in mind, all this is just on fresh mix. Okay, this is just on fresh mix. We have a whole new set of stuff on sample testing. Now, I think this section would probably be a little bit shorter because we did the same thing like 3 times. We did it at 7, we did it at 14, we did it at 28, but we did the same thing. So let's talk about sample testing. What did we do for sample testing? So let's talk about the cylinders. So walk me through. What do we do when we do cylinder testing? We go to the lab, we pull the samples out of the bath, right? So pull the samples. Do we just put them into the press and crush them? You're shaking your head no. Why? We dry them off and we measure them, right? Measure them. We cap them, load at controlled rate. Then we also have the beam tests, which is kind of follows the same thing. You know, you can kind of follow that. Okay? All right? So the test procedure section, however your group wants to do this, if you want one person to write it and one person to check it, if you want to break it up and say, okay, you handle this part, you handle this part, you handle this part, that you write the section that you did, that's fine too, okay? But just to give you kind of an idea, there's a lot of stuff that goes in there, okay? So what do I think are your most handy guides for this? So lab handouts. Because the lab handouts are going to have like the names of the various, pieces of equipment and calibrations and all that. But 2, notes during week 8. Okay, right? Those are the notes that you all took while Patrick and I did the demo for you. Okay? Make sense? Okay. I'm curious. We're all together. Is there anything that we forgot here? And it's okay if we did. It's not. These aren't trick questions. I'm not like, did you forget to put the KSI? No, this is us. Is there anything that we forgot? Anything worth mentioning on test procedures?
Do you want pictures of equipment or something like that?
Let's talk about that. So, okay. So, I'll put like this. I'll put stuff to include. So let's talk about equipment, okay? Pictures of equipment. Pictures of equipment, I would definitely say, if you can, do it, okay? And by the way, every single person in this class has card access down to the lab. You go down to the lab and take some pictures of stuff right now. You can take pictures of the Gilson compression testing machines. You can take pictures of the you can take pictures of anything down there. You could go do that right now. That's not really a big deal. But one thing I'll say for pictures of equipment is if you're going to include equipment, I would include equipment. Okay, what I mean by that is this is a documentation of your experiment, and one thing that I don't think is very, I'll say, noteworthy is needing to take a picture of a pie tape. We can go buy a pie tape on Amazon. But the large-scale equipment that you use, the cylinder testing machines, the Tenius Olson for testing the beams, that's fine for inclusion. That's totally fine. Okay? That's totally good. What I wouldn't include, let's talk about this. Let's have a discussion of what not to include. talk about what not to include. What I wouldn't include in terms of images are your ASTM cylinder brake patterns. In other words, remember how we would have a cylinder we say is it type 1, type 2, type 3, type 4? Because that's an easily referenced guide that you could find no problem. We could Google that and find it in 5 seconds. Okay? And that's consistent across the board. I don't think that you need to include something that's readily available to anybody doing cylinder tests in the United States. But not everybody used our cylinder testing machine. Not everybody used our Tenius Olson for the beam brakes. Okay, does that make sense? All right, any questions about that? Okay. I'm going to skip ahead a little bit. I'm going to skip the data reduction and calculation section, because if there's any one thing that I think is going to be valuable for us as a group, it's to discuss sources of error. Okay? Does everybody have this? I'm a dork, I know. I'm getting a lot of Instagram, coverage today.
It's showing on the Instagram. I hope you know.
Okay. Everybody got this? Okay. All right. I think what is probably the most valuable for us, and this is where I want everybody to chime in. Okay? All right. Okay. How do I want to organize this here on the board? Let's talk about sources of error. So, let's see, we have sample prep. Okay. Let's do this. So I'm going to call on each group, okay? All right. So what we're going to do is I'm listing 6 sort of points here on the board, this grid of 6. Okay? We're going to talk about mixing, temperature, slump, air content, casting, and other. Okay, so you as a member of your group should have a pretty good understanding of the errors that you think your group experienced. But I don't expect group 1 to have innate knowledge of what happened in group 5. Okay? So I'm going to start calling on people. Let's start off with mixing. So the process of actually mixing your sample. So let's start off with group 1. Group 1. Where are my group 1 folks at? Okay. So is there any sources of error? And it's okay if the answer is no. Like, you don't have to have a yes answer to every one of these. Is there anything notable during the mixing process that you saw could lead to an error in your later experiments?
Nothing that jumps out immediately.
Okay. Group 2.
We didn't have anything in mixing.
Didn't have anything in mixing? Okay. Group 3. I've got something in my mind for everybody, but we're going to see. Let's how about this?
Did we mix wrong at the wrong timing? Was that the one we did? You know what I'm talking about?
That was the first time.
Okay.
Yeah.
I couldn't remember that
I think
one.
we did this one, right?
Did you have any material that was lost, like dust?
Oh, yeah.
Dust, Caleb? Everyone's like calling that dust.
Did you spill anything? Did you spill any material?
Yeah, we did, so.
Did we?
I forgot about that.
What group number are you?
Well, it doesn't matter.
No, no, actually, no, it does, I'm serious, what group number?
Group 3.
Okay, all right, so see right here where it says spillage, I'm gonna say group 3. So, no, I mean this, because I'm not calling you out, this isn't like you did anything wrong, stuff happens, it's okay. We need to know what happened, okay?
But we should be also like talking about everyone's error, kind of, right?
Yeah.
Okay.
Yeah.
Gotcha.
Especially when you start making data reduction, calculation, conclusions, etc. Okay? Like for example, let's say your group cylinders are much higher than everybody else's. Well, why do you think everybody else's are so low? You know? Like, did you do something right that everybody else didn't, or did maybe you measured your water wrong and everybody else did it right? You know what I mean? Like, we gotta talk about that. Okay? How about this? Any material loss, dust, spillage, anybody, we're supposed to measure out this many milliliters of admixture, and you maybe got a little bit too much, maybe not enough.
Group 1's water was wrong.
Group 1, okay, so see what I mean? We're starting to come up with stuff, okay? These are real sources of error, okay? And don't worry, we're going to have a section just like if it doesn't fit neatly into one of these boxes, we'll have a discussion there. So, okay, let's move on. Temperature. Is there any? Yes.
I thought of one for our group. We didn't realize that there were 2 buckets of the gravel, so we added that in, like the second one after.
Okay.
We did that as well, group 6.
So, all right, hold on. Let's lower this a little bit.
Okay, so
So group numbers what and 6 and what?
5.
5, 6, out of order, gravel mixing.
I blame our gravel error on the people who prepared the lab because they like put it away.
Yeah, they definitely did that thing.
That's okay. No. I'm not kidding. That's
So you
okay.
actually sabotaged our experiment is what we're saying.
Well, we kind of did.
Yeah, that's true. It's Loki didn't affect us that much. We had some period.
Patrick's the older man. Stop.
I'm blaming Mike, not Patrick. See, it's actually Kyle's fault.
It's Kyle's fault.
You can't carry the bucket.
I'm not blaming Patrick. I'm blaming Kyle. Patrick's tough.
I told you this is going to be a valuable discussion today. Okay. All right. Anything else on mixing? Okay. How about temperature? Were there any real errors on the temperature test?
Miscalibrations of the device.
Yes.
Could ours have been affected where it was outside?
Okay, what group number?
4.
4. Okay, let's talk about that. Group 4.
We weren't in the direct sun though, but I'm sure it's still.
No, but group 4 was outside. Like, here's the thing. It's not necessarily to say that there was something wrong with what you did versus what the other groups did, but if for some reason the data shows your temperature is just off from everybody else's, it's a reason for that. How many of those of you that were not in group 4 remember that group 4 was outside? Not. Do you see my point? Like, I mean, that's why we're having this discussion. Okay. So group 4 was outside, so that'll affect that. Did anybody pull the thermometer out early? It's okay. Like, I didn't expect to have a total or a significant amount of errors with the temperature. you pile the concrete up on the side of the bucket, or side of the tray, stick the thermometer in, wait, record a reading. Like, that's basically it. Okay. All right. Let's talk about slump. What were some errors or some issues that you all noticed during your slump test? So let's just sort of get back into the headspace of the slump test. So, got your platform, got your cone, step on the sides, place it in 1, 2, 3 lifts, 25 rods apiece, lift. Okay, so, yes?
We used the wrong thing to tamp it.
Yeah, what group number? 1. So there was, you know the device we used to cut the cylinder mold off? There was one group that used that for tamping.
I didn't know like how easy it would release, so I kind of took my feet off, and then it kind of gave way, and then I slowly pulled it.
So, okay, so what group number? 4. Okay, so there's a couple of things you mentioned there. Okay, so with group number 4, like, you have your feet on the bottom, okay, you put the concrete in, like, the concrete is pushing down. It wants to escape the bottom of the cone. And so if you don't keep it pressed down, it will want to bubble out. So concrete bubbling out of the bottom. So concrete bubbling out of the bottom, and then a slow lift. Is that what you said?
Yeah.
Okay, what else? Yes?
Whenever I picked up the device, it didn't come out, and I had to shake it.
Oh, like the concrete stuck to the cone?
Inside, yeah.
What group number?
1.
1.
A lot of issues.
What?
Been a lot of problems.
You're the common factor.
I'm pretty sure it was right.
Also do the bubbling thing. I feel like we did that. I feel like it actually got moved a little bit.
What happened?
I feel like ours, like, also, like, we lifted it up, or like, someone's foot, I think, didn't quite step on it. Yeah, who did it?
I
Did you
think
do
it
it?
moved forward, and that
You're welcome. You're a little bit.
Like the cone slid?
it slid, yeah.
Something like that.
What group number?
3.
3.
I was like, I know there was something that we did.
Yeah.
Right. Cone slid a little bit.
Cone split. Okay. What else? I haven't heard anything from group 2.
Apparently
I don't think we did have any issues with something.
Okay. Was it the air content?
It was the air
It was
content.
the air content. I remember, I was like, I knew group 2 had something
Yeah,
wrong.
that was
Had to get you for something. Okay. So, any other slump errors y'all can think of? Okay. There is a very indirect lesson I'm teaching today, which is that whenever you do lab experiments, the sooner you get this stuff down, the better, because now we did it like weeks ago. We're like, what happened in the lab? So, yeah. All right, air content. Group 2, what happened?
We put it in, and then it just didn't really.
Yeah, we could, so group 2 couldn't pull a seal, couldn't pull a vacuum. So what happened with group 2 is they, they were following the directions, but like to the letter. But I don't know if it was just the gasket, the little rubber gasket was failing or whatnot. But I mean, pumping, it was just, they couldn't actually get a vacuum in there to read the air content. So it just didn't happen. So when you review your data for the class, there's not going to be an air content reading for group 2. There just isn't going to be one. It is what it is. So. What other errors with the air content test do you think happened?
We forgot to use the mallet on the side of the thing that.
Okay. Group 3?
Yeah, great.
No consolidation.
Didn't you also say, like, it needed to be on the, I don't know, like, you know how there's a number on it, and you had to put it to that number?
Yeah.
And you had to be on the down press.
Yes.
It was, I don't think ours was.
Okay. All right.
We kind of, like, got it there, kind of.
So 3?
They should've.
Cause I think it was like
Yeah.
3 bars, I don't know.
So, didn't, hit target on the down press. Okay, didn't hit the target on the down press. Anything else on air content?
Matt said he had something.
It wouldn't shoot out the other bleed valve. So we put one.
Yeah, which group, what? 4. I remember one group had that issue, so 4, I'm gonna put it up here. Water didn't exit both bleed valves. Good. I like this. All right. Any other questions or any other things that popped up? All right. Let's talk about casting. I feel like we're going to have a couple things to say about casting. About casting, I'm talking about the cylinders and the beams.
So that's like when we put them in the little plastic cup things.
The cylinder molds, yes.
Yeah. So some of ours weren't tamped correctly and they had a lot of pockets in them. We were able to figure that out when we got them out.
Poor tamping.
Yeah, that'll work.
Group 6.
6? Oh,
Yeah.
well, that's good.
I mean, group 4 is associated with mistakes.
So, all right, what were you going to say?
We also didn't start mounting the sides until like halfway through.
Okay, so what group number?
3.
3. Okay, so what you're saying is inconsistent consolidation.
Yeah.
We were like, oh.
Yeah.
By the way, is this valuable? Is this helping?
Yes.
Good. Okay, that's kind of the plan. Yes.
Group 2 also, I think for our first lift on the beam, we forgot to use the mallet.
Did we also forget to do the tamping for like the first one we did the tamping?
No, we did the tamping, we didn't do the mallet.
Okay, we should
Didn't mallet the first beam lift. Okay. What else?
I would say we had inconsistent tamping, because our first 2 that broke were pretty weak, I think, if I remember correctly.
Group 1?
1.
Now, is this the rodding or the tamp?
The tamping.
Okay. All right. Did every group get 25 rods on every lift for all 9 cylinders?
I miscounted at least once.
Group 1, right? Okay, so
I got the 5.
that was a trick question because I know somebody in here did that. You know what I mean? And by the way, like I'm making these notes based on who's saying it, but let's also be clear. There's a good chance this list that I'm putting here on the board isn't comprehensive. I mean, there's a strong possibility that you all are going to leave. Oh, I miscounted rods. Okay. What else?
Using the rod, you were only supposed to go so far in the concrete.
So are you saying incorrect depth?
Everything wrong. I just wanted to check. Yeah, that's how I did that.
Okay. What else?
Christian did better this time. We're good.
Source of error, Christian.
You wore that like a badge of honor, sir. Oh, man. Okay. Any other errors just like across the board? And by the way, these other errors, let's also add on test days as well. So like what errors could have happened throughout the process as a whole when we did our testing.
For our 8th cylinder break, we did it at full advance.
We did.
You did?
Yeah. It broke really quick.
I bet. Thank you for being honest with me. Okay. Okay.
Why is that?
What?
Why is it so bad? Does it not just get it done faster?
That's what, I mean, if you distill everything in the ASTM standards, just get it done as quick as possible. That's the process. What other errors could have happened across the board? Any errors that you all noticed on test days?
During the beam test, if the 2 points weren't perfectly even.
Okay, so surface contact on the beam test. I'm going to give you 2 errors, by the way, that apply to everybody. You reuse the fresh concrete that you would do the air content test, and you're not supposed to use that concrete to make cylinders and beams. Well, we did, right? Here's another one. I'm writing this kind of quick, so I know my handwriting's a little off. But equipment calibration errors. Is the equipment off? You know, I mean that is going to affect your data. You know, that's going to affect everybody. Group 5. I don't see much here on the board other than group 5. Anything?
Oh my God. Trying to act like you're better.
Just look like we were just awesome. Like what am I?
It was smooth sailing the entire time.
No,
Pretty
we
close.
I would like to point out that group 6 is not on there very much because ours were the best, like by far. That's true. Hold on.
I did have a question. I was looking at the data and the temperature test for group 1, their temperature is like 7 degrees hotter than everyone else's. So I didn't know if like
You're just putting more on group 1?
I just like, if we were to discuss that,
Yeah, overall,
like what would?
We've got some shade.
You wanted to get away from your area.
There's some whataboutism going on here. What happened in your? Well, what happened there? I don't know. That's a good question, and let's actually. I do want to talk about that because I want to talk about the data here in general, and maybe we'll make some general observations, some discussions and conclusions about the data overall. But other than like stuff that you did that could be controlled or changed, et cetera, anything else that we're maybe missing? And again, this is not. I guarantee you this isn't a comprehensive list. And I am not even, what I'm trying to do is get you thinking about as you write the report. This is the type of stuff I want you referencing, okay? Make sense? Okay, let's talk about graphs and data and then sort of synthesize that. Got to pose for the pictures, yeah, Instagram. Okay, did everybody get all this?
Yeah.
All right. Everybody get this? Okay. So let's erase this. Going once, Going twice. All right, so let's, this is why I didn't prepare any notes for today, because it's like, this is, just an organic discussion we gotta have together. Okay. All right. So let's talk about graphs, data, conclusions, etc. Okay? Here, computations. Okay, so let's see if we can identify the meaningful ways that we should distill our data, present our data to make some meaningful conclusions. Some of this is going to be easy, some of it's not. Okay, some of it's going to take a little bit of work. And actually, that's that's an inaccurate way of saying it. I think it's all going to be easy, just some's going to take a little bit more work than others. Okay, so what data do we have? Let's start off with fresh mix. So for fresh mix day, we only have 3 data points. We have temperature, or air content here, but we did some. Let's do it in the order that we did it in the lab. Okay. Okay. So how would we present this? What would be the easiest way of presenting it? Well, let's see. You could have tables. You could have bar charts. Maybe you have, here's this group, this group, this group, this group, etc. Or you could just list it in a table, whatever you think makes sense. Okay? But based on the sources of error that we've discussed and based on the performance of what you did in the lab and how it compares to everybody else, I think we can come up with some meaningful conclusions. With each one of these sections, what you kind of want to do is let's say temperature. You say, okay, here's the temperature section, table such and such, or figure such and such includes the data for this. Here it is, and put your figure title and then move on. So I feel like this section, when it comes to writing, is going to be very sparse. When it comes to figures, it's going to be pretty heavy. Okay, so just keep that in mind. All right? All right, so fresh mix, I think, is pretty easy to do. Okay, let's talk about cylinder data. Okay, so a couple variables to consider. You've got a lot more data here. Okay, so number one, you should look at statistics. And what I'm saying, and when I say statistics, I mean trends between groups, trends across time. Like how did everybody's 7-day tests compare to 14-day tests, compare to 28-day tests, etc., right? So you've got a couple different ways of looking at it. There's also measurement differences. Okay, here's an example of what I mean by measurement differences. Compressive strength using caliper. Diameters. And FC prime using high tech. measured diameters. What does the data look like? Is it more consistent with pie tapes? Is it less consistent with pie tapes? I don't know. You tell me. By the way, I noticed how nobody on sources of error mentioned misreading a pie tape, misreading a caliper, not having the caliper. Like, here's one. Here's the cylinder. The caliper needs to be perfectly flat. Did anybody maybe do a caliper reading where it wasn't at 90 degrees? Maybe it was a little off? You know, something to think about. Okay. So, from these, again, tables, bar charts. Okay. So, for the beams, not really a whole lot to say, just, you know, FR between groups. There's not really as much data. But for the conclusions and the discussion, let's see if we can come up with some questions to answer. All right? Okay. Everybody got all this? Because we're going to come up with some questions. And let me be clear, I'm not saying in your report to just start listing answers to these questions. But I've said before, I want your discussion to be clear and complete. I want it to be comprehensive. Okay? So let's see if we can go through all this. All right? Does everybody have all this? All right. Let's list a couple questions. Question 1. Let's see, how do I want to write this? Getting ahead of myself. How does fresh mixed data compare across groups? All right. Question 2. How does your group's cylinder data compare with class trends? How does your data and the class's data change with respect to time? Any appreciable differences between calipers and pie tapes? How about how does FR compare with FC prime? And I'm just like spitting out some questions, by the way. I mean, I'm not, you know, this might not even be complete. But there's a question that you think you should consider in your report, spit it out. Okay, but how does FR compare with FC prime? Here's one. Any trends with cylinder brake patterns? Like the type 1 to type 6. Like, are there any trends? Like, did everybody have a type 3? Or was it group 2 was the only group that had type 4s? You know? I don't know. You know, is there anything there? Here's one. Big one. I love this question. What would you do differently if you had to do it again? And again, I'm not, I want to be clear, I'm not asking you to specifically list, you know, this question, but maybe in your discussion, you know, you're thinking, okay, here's how the beam test would work. We had a contact issue when we did our beam test, so we probably make sure that we filed that down really good before we tested it if we had to do it again. Trying to think of other questions that you should consider on this rainy day. It's coming down. Was it a fun lab? I'm just curious. Having fun doing it?
So fun.
So fun.
Just a quick, when it says attached one representative set of data sheets.
Just do your own group's data.
Just like those 3 sheets that week, okay.
Well, actually,
Oh, yeah.
it would be 5, because there's the fresh, the 7, the 14, and for 28, there's 2, because there's the cylinder test and the beam test.
Gotcha, okay.
There should be 5 data sheets. And if you want, you can screen clip them at an image in Word, and then just, you know, do that, and then just PDF the whole thing, so.
So no 30-page appendix, like you said before.
Yeah, let's not do that. Let's not do that. I mean, I've got all the test data for everybody. Let's just put your own in. Let's just do that.
So this is gonna be, like, there's gonna be a lot of pages probably.
Oh, it's going to be a big report. It is. But I mean, like, what I'm trying to do in this, here's what I'm trying to do. Let's take all the sources of error that we discussed. Is it really going to take that much effort to put a couple pages together on sources of error for the project now that we've discussed it as a group? Okay, well, there's a couple pages. Is it going to take a couple pages? Is it going to be that hard to describe the test procedure in your own words? Shouldn't be, now that you've done it, you've got your own notes, you've got the notes of everybody in your group, you've got the test procedures. I get that it's going to take time, but it's not going to be hard. That's my goal.
Is there like a, like, I don't want to say like limit or anything, but like especially for like the graphs and data, like I feel like there could be a lot.
Oh, yeah. I mean, like
you're expecting a lot of different graphs.
I'm not. Let me just say this. I'm not expecting like if you turned in a report that's 20 pages long as opposed to 30 pages long, but oh, you did something wrong. But let me also say this. So a standard Excel chart, like you can fit about 2 on an 8.5 by 11,
yeah.
And then you're going to go on to the next page. So what I'm saying is, like, I don't want you to get scared when I say this report could very easily be 30 pages long. That's not like anything that should intimidate you, because I'm not saying you're going to write 30 pages.
Yeah.
I'm saying, here's what I'm saying. You've got bulleted lists, you've got figures, you've got tables. That's just going to, appendices, tables of contents, that's just going to take up space. It just is. So.
That's kind of what I was thinking.
Yeah. It's just that, yeah, so. All right, this isn't, let me say this isn't a comprehensive list of questions. I mean, it can't be. I can't literally think of everything. But just use this as a North Star for when you prepare your report, okay? And I'll say one final thing. I want this down here. We actually skipped a section together. We skipped the introduction. Okay, my advice on the introduction, write it last. Write it last, okay? And the idea behind the introduction is you got a 30-page report. I don't want to read 30 pages, I want to read a page. Tell me what's important in that page, okay? And you're not going to be able to do that until you've written the whole thing. Or, let me qualify that. You could do it. You could write the introduction first, but I guarantee you it will be better if you wait till the end. Like, I'll tell you this, I mean, something kind of, I'm a researcher. I write papers and whatnot, and there are these conferences that they say, you know, submit your abstract and then submit the paper. And I'm thinking, the abstract's no good if you don't have the paper already written, you know, because the abstract summarizes the paper. So, honestly, you kind of have to have either like a good idea of what the paper's going to look like or something kind of ready to go in that fashion for when the conference or the journal comes up. You want to write the, you want the abstract to summarize all that. Don't forget, I do want a statement on generative AI. Again, like I said, I don't care how you do it, as long as you tell me how you do it, okay? Just be straight, be candid how you do it. Make sure that your discussions are clear, convincing, and complete. And the one thing I really think is a bad idea is to have ChatGPT do the math, even though, I mean, this is really, really easy math. This is sigma equals P over A and pi d squared over 4. I really think it would be faster because to do it in Excel than it would be to ask ChatGPT to do it. I mean, you do have to get or you do have to like get all that data, you know, from the lab sheets. And if you're typing that in Excel, you might as well just add a column and do the math. So that's just me. But I do think generative AI is really great for brainstorming. I think it's great for proofreading. You know, that's fine. That's okay. So yeah. Any questions about the lab report? Yes.
For the test procedures where we couldn't do the air content test, you want us to say like in this step, you want us to say like attempted to perform air content?
That's a great question. That's a great question. So here's what I would say is write the test procedures question as if this is how to do it.
Okay.
And then write in your conclusion section, it didn't work, you know, you know what I mean? So that's a great question. That's what I would do. A lot of times what engineering firms will do is they will have a standard report template that describes their test procedures and then the data changes. So I'm thinking of the test procedure section as that standard template that wouldn't change. So imagine taking this lab report, doing the experiment again, hopefully it would work, you would just be changing the conclusions, not the procedure. So. Sound good? No class on Thursday. And kinda no class in structures on Friday. So on Friday, just so you're aware, we're going to be doing a troubleshooting Q&A on the project in case you've got any mass tan issues and whatnot. So that's what we're going to be doing in class for structures. So tomorrow in structures, we're going to do our 1D bar analysis. No class in here. Thursday, Friday, we'll do our troubleshooting. But I'll stick around here for a few minutes if anybody have any questions on their project. So, sound good? Well, there's a couple people in here that don't have me for structures. For those of you that don't have me, have a wonderful break. That's all I got, everybody.